connection. Determine line and phase voltage for the data connected system. Determine the line and phase current for data connected system. Drawing label the phasor diagrams for the data connected system. State the limitations of the data connected systems and the connected data connected load. So this is a data connection. In this case, this connection you see that U1, U2. So U2 connected to V1, V2 connected to V1, the U2 connected to U1, and then connected to supply. This is a data connection. So this is a voltage, so the three-phase data voltage. So the red, blue, and the black voltage. So in this case, this is the between U1 and U2, V1, V2, and the V1 to V2. So this data connection. So this data connections you can see the data diagram. So that data. So in this case, the phase and line voltage you can calculate it. So this is a VA says a line voltage. Similarly, the VB and the VC is a line voltage. So the V line is equal to the VAB. Also, this V line also equal to VBC and V line also equal to the VCA. So this data connection is a voltage and current relationship. So line voltage are the same as a phase voltage. V line equal to VB. And the line current IE is a line current IE is coming here. And also line current IB and line current IC. Then go to the IAB, IBC, and ICA. Those are the phase currents. So the line current is the difference between the two phase currents. So if you want to calculate the IA, the equation the IAB minus ICA. So this is the IA. Similarly, the IB. IAB can be calculated IB and sine theta. So the IAB is an angle 0 degree. IB is IN sine theta minus 120. So this is IBC IN minus angle minus 120 degree. ICA is IN sine theta minus 240. So ICA equal to IN angle minus 240 degree. Line currents are equal to the IA equal to IAB minus ICA. So this is the we see a better diagram. IAB is IN, ICA is IN. So that then IA is equal to IN minus IN 100 minus 120 degrees. So this is that you can calculate. So that can, this current is IA equal to root 3 IN angles are minus 30 degrees. Similarly, therefore the data connection free and currents are voltage and current relationship. Line voltage are equal to V equal to the phase voltage. Line voltage equal to phase voltage. V equal to VB. Line current equal to difference of the two phase currents. I equal to I phase 1 minus I phase 2. So this is also equal to root 3 times I phase. So then we have to calculate that determine the current for a three-phase motor stator winding, which has an impedance of the 20 ohm per phase when it is connected to the 450 volt 50 hertz supply. So in this case, the three resistors, 20 ohms are connected between across A, B, B, C, and CA. So that the voltage is a 450 volt 50 cycle per second. VV equal to VI equal to 450 volt. Similarly, IP can be calculated. The VV divided by ZB. Then we also calculate 415 divided by 20. We got the 20 by 75 ampere. IA equal to root 3 times IB. So root 3 times 20 by 75 ampere. So then you got 35 by 94 ampere. This is the line current calculated. The next problem, determine the phase current for the three-phase data connected transformer, which deliver is a 40 ampere when it is connected to a 11 kV 50 hertz supply. So in this case, this connection is connected. So this is ABC data connection. So in this case, the voltage line voltage is 11 volt, 11 kV, 50 hertz. Line current are 40 ampere. Then we also calculate the IAB. So this is phase current. Line current IA divided by root 3. So the I phase is equal to 40 by root 3. You got the 23 by 1 ampere. Similarly, the next one is we have to determine the phase current for a three-phase data connected resistive load, which is a line current of 34.6 ampere. So in this case, we make the connection ABC, the data connection. So 34.6 ampere is the line current. The IAB is the phase current. IB equal to I by root 3. So the 34.6 by root 3, you got the 90.98 ampere. The next one is determine the line current for a three-phase data connected resistive load, which has a phase current of 100 ampere. So this is the ABC. We made the connection here. So the 100 ampere connected go from the A to B. Line current I is a root 3 times I phase. So the 100 multiplied root 3, you got the 173.2 ampere. Determine the phase voltage and the current for a balanced three-phase data connected resistor load, which has a line current of 100 ampere and a phase impedance of the 20 ohm. So this is a 20 ohm phase impedance we connected. So the 100 ampere following into the IAD. So IB equal to I divided by root 3. So then 100 divided by root 3, you got the 57 by 74 ampere. V equal to V phase equal to I phase multiplied Z. So the 57 and 74 multiplied 20, you got the 1.154.84. The next one is the determine the line current for a three-phase motor, which has a balanced impedance of the 20 ohm phase when it is connected to three-phase 400 volt 50 hertz supply. So in this case, we calculated the line voltage are the 400 volts are 50 hertz. So the resistance are the 20 ohm connected. The phase current had to calculate that. So in this case, VB equal to V equal to 400 volt. I equal to VB by ZB. So 400 by 20, you got 20 ampere. I equal to root 3 by IB. So root 3 multiplied by 20, you got the 24 by 64 ampere. So this is the biggest one. Next one. Three-phase star data system. Star data system. So the sort of problem is low voltage AC circuit, star data system. And then in all of this lesson, students should be able to identify interconnected star data system, show the relationships between the line phase voltage and the current for a three-phase system, take the effect of the passing phase winding in the three-phase system, connect the star data system. So in this case, this is a star connection. The voltage and current relationship is a line current equal to the phase current. This is a star connection. So this is I equal to IB. And also the current and the neutral current is equal to the neutral current plus IA plus IB plus IC equal to 0. Line voltage is equal to difference of the two phase voltage. So this is equal to V equal to root 3 times PT. And the data connection, voltage and the current relationship. So line voltage is equal to the phase voltage. V equal to VB. Line current equal to difference of the two phase current. So I equal to root 3 times I phase. Where to calculate? Determine the line current of the three-phase data connected motor, which has an impedance of 24 ohm phase when it is connected to a 240 volt star connected transformer. So in this case, we connected a 240 volt star connection, and also data connection is a 24 ohms are connected to data. So in this case, the supply voltage VB 240 volt, V equal to root 3 times VB, so that root 3 times 240. So you got, and also the VA equal to 415 volt. And so that in this case, VA equal to 415 volt, VB equal to 240 volt. In this case, VA equal to VB for the data connection. So IB equal to VB by ZB, so you got 415 by 20 volt, you got the 7.32 ampere. So I equal to root 3 IB, so root 3 multiply 7.32, you got the 30 ampere. So this is the way we calculate it. The next problem. Determine the current of a three-phase star connected motor, which has an impedance of 24 ohm phase when it is connected to the 240 volt star connected transformer. So this is a star connection transformer, 240 volt, or the supply voltage 240 volt, and also the star connection 24 ohm. So ABC supply. So in this case, the supply is V equal to root 3 times VB. So in this case, VB equal to V divided by root 3. So the IB equal to VB by ZB. So 240 by 24, you got a 10 ampere. I equal to IB equal to I equal to 10 ampere. This is for the star connection. Data connection.